So today we're briefly going to talk about what current, resistance, and voltage are, and then we're going to also talk about how they're related in Ohm's law and do one quick practice problem. Okay, so let's look at current first. So current, again, I think of like a river flowing. It's going to be the rate of flow of electrons, but that river is in fact electrons. So this is the flow of electrons in a circuit. And to be more exact, the current is how much charge passes a given point in a circuit in however many seconds. So it's going to be the units that we'll use for current. I'll go ahead and put the units up here. Are going to be either coulombs per second, or we'll write amperes, or we can just abbreviate that as amps, or just A. So any of those things are appropriate units for current. While resistance is how much a material resists the flow of electrons. Resist the flow of electrons. So materials like that are, let's say, like plastic or something like that, those are going to have a really high resistance because it's going to be really hard for electrons to get through. While something like copper wires are made of oftentimes, it's going to be really easy for electrons to flow through that, so they're going to have a pretty low resistance. And the units we use, I'll go ahead and write that down. So the units we use for resistance are going to be omega, which is the Greek letter, or we can just write out ohms. So voltage is like the pressure from electrical circuit's power source that pushes electrons through a circuit. Or we can define it as like amount of potential energy between 2 points on a circuit. So let's go ahead and write both down. So it can be the amount of potential energy, and also should say electrical potential energy, between 2 points. Or we can think of it as it's like kind of like a water pump, if I think of like an analogy to like a water tank. So the voltage is the pressure from an electrical circuit's power source that pushes the electrons through a circuit. About that. Through a circuit. Great. So, and units for voltage, you can kind of think of it, it's going to be like joules per second. So like how much energy change per second it's creating. We can also, though, for units, it is going to be just volts. Pretty handy, makes sense with the voltage or V. Or you can say V for the units. Okay, so now we're going to go ahead and talk about, excuse me, sorry about that, Ohm's law. So Ohm's law just tells us how the voltage, current, and resistance relate. So this case is voltage is proportional to the current times the resistance. So again, I is current measured in amps. V is voltage measured in volts. And R is resistance measured in ohms. Cool. Well, so now let's go ahead and use Ohm's law to solve a quick little circuit problem. Cool. So let's go ahead. I encourage you to try it yourself first and then go ahead and check back in on the video. Okay. So after you've done it, let's go through it together. So we have, let's see, an electrical iron with resistance of 49 ohms is connected to an electrical line with 120 volts of voltage. A, what is the current in the iron? So again, I always, whenever I solve a good old physics problem, I always write down my givens. So let's see what we have. Voltage is what? 120 volts. Current we want to find. And resistance is 49 ohms. Cool. So let's go ahead and put it all into Ohm's law. V equals IR. The voltage is 120. Current we want to find. Resistance is what? 49. And I'm getting I to be 2.45 amps. Cool. So now let's go ahead and go on to B. So how many electrons would flow through a cross section of a wire in 30 seconds? Okay. So when I think of this, I'm thinking of electrons flowing. That's got to be related to current. So let's go ahead and go back through our handy dandy toolbox. Our current equation, I know, is change in Q over change in T. So let's write down our givens. So I, we already know, is 2.45 amps. Delta Q, I don't think we know that. Delta, oh, we have a time. Cool. 30 seconds. Love that. Okay, so let's go ahead and put it in. So I is what? 2.45. Delta Q we don't know. And this is 30. Okay? So I'm going to go ahead and solve this. And I'm getting delta Q to be 73.5. However, let's keep in mind the units. Q is measured in coulombs. So this is going to be 73.5 coulombs. Okay, it's asking for electrons. However, I know coulombs and electrons are related. Oh, so I'm going to go ahead and look at my handy dandy conversions. And I know that there are 1.6 times 10 to the negative 19 coulombs on every electron. So that's the charge on electron. So I'm going to put that in. So one electron has a charge of 1.6 times 10 to the negative 19 coulombs. Cool. So now I can go ahead and see, oh, coulombs cancels. That's so fun. And I can go ahead and make sure when you plug this in your calculator, you're always using parentheses. I'll go ahead and put it up here. So I'm getting 4.59 times 10 to the 20th electrons. Cool. Thanks for watching.